How much power must a 24-volt generator furnish to a system which contains the following loads? So we have these different loads on the system, and whenever we say we're reading this and we see it says how much power, right? So when we think power with electricity, we should automatically be thinking the watt, right? Usually the equation we'll also be using when we hear the word power is going to be pi. Sometimes we may need to use ear to solve for the voltage or the current to plug it into pi, but usually when I read the word power or hear the word power, I'm thinking pi. All right, so we have these different loads. We have 1, 2, 3, 4 different items that this generator is supplying power to, right? And we're trying to find out how much power that generator is supplying. So let's start with the first ones. We've been doing these motor problems. So we have one motor is 80% efficient and has 1/2 horsepower output. So we have our output here. We know the shaft is turning with 1/2 of a horsepower. So let's just go ahead and convert that to electrical power because that's what we're going to solve for our input in electrical power. So we'd have this turned out to be 1/2 times 746. There's our conversion, is 373 watts. All right, so with that information, what we're trying to find is the power that this input or the battery is supplying to the motor. So we need to know our equation again. Efficiency is equal to output power over input power. So we know our output again is 373 divided by our input equals our efficiency of 0.8. It's the same steps over and over. Again, at the end of the day, you'll do them enough times, you know you're just going to divide by the efficiency. We're going to multiply both sides by I. So we're going to have 0.8I equals 373 divided by 0.8 divided by 0.8. And like we said before, we're really just going to take our output and divide it by our efficiency. And that input power, so I'm just going to go and convert it back to, just turn it back into a P, is going to be 466.25 watts. So we found the power for a motor. So let's go to scenario 2 or load number 2. All right, so load 2 is 3 position lights and they're 30 watts each. So when I read 30 watts each, I should think, oh man, that's easy for me because they already gave me the power of the lights, right? So I have 30 watts, but that's only for one light because it said for each, right? So I have 3 of them, therefore I will have a total of 90 watts. So we have 90 watts so far, 466 watts. All right, let's look at our scenario or our load number 3. One heating element, and it has 10 amps. So again, when we're solving problems, we're going to write down everything that we know. We know the amps. So we know I is equal to 10 amps. So what else do we know? Well, the problem tells us that it is a 24-volt generator, right? So we also know the voltage. The voltage is going to be 24 volts. So we're going to go back to our equation, pi, and solve for power. So P equals I, which is 10, times E, which is 24. Therefore, for that heating element, it needs to have 200, or it uses 240 watts of power. So there's number 3. And finally, we have number 4, similar to number 3. It tells us the current that is being used by each of these lights. And we, again, know that it's a 24-volt generator. And we know the current for one light is 4 amps. So we're just going to use the same equation. We know that the current is 4. And our voltage is 24. And that comes out to be a total of 96 watts. So one thing we need to make sure is that we read it carefully. It says 2 lights, right? So we're going to go ahead and multiply that by 2, and that will be 192 watts. All right, so now we have 1, 2, 3, all 4 of our power sources, all 4 of our these loads that is using up power from the generator. So we're just going to total them up. 466.25 plus 90 plus 240 plus 192, and we just add those up, and that's going to be the total power that is supplied by that generator, and the answer is going to come out to 988.25 watts.